In the previous video on LDL metabolism, you saw how dietary and endogenous cholesterol, in the form of cholesterol esters, is delivered from the liver to peripheral tissues via LDL. However, excess free cholesterol is toxic to cells. To maintain cellular homeostasis, this excess cholesterol must be returned to the liver for excretion. This process is known as reverse cholesterol transport and is mediated by HDL. HDL carries excess free cholesterol from peripheral tissues back to the liver, where it is ultimately excreted in bile, either as bile salts or as free cholesterol. HDL serves as a reservoir for several apolipoproteins, including ApoC2 and ApoE, but only ApoA1, its main structural protein, will be shown in this animation. Let's now examine this process step by step. Nascent ApoA1 is synthesized in the liver and small intestine. In the interstitial space, ABCA1 transporter facilitates the efflux of free cholesterol and phospholipids from hepatocytes, enterocytes, and other peripheral cells. These free cholesterol and phospholipids associate with ApoA1 to form discoidal nascent HDL particles, which then enter the lymphatic system and eventually into the blood circulation. In the blood plasma, nascent HDL interacts with lecithin cholesterol acyltransferase, or LCAT. This enzyme transfers a fatty acid from phospholipids to free cholesterol, converting it into cholesterol ester. Because cholesterol esters are hydrophobic, they migrate into the core of the HDL particle. This transforms the discoidal nascent HDL into a spherical mature HDL particle, or HDL3. Mature HDL particles have a longer half-life and continue to circulate between the blood and interstitial spaces. While in the interstitial space, they acquire additional cholesterol and phospholipids from peripheral tissues and macrophages through ABCA1 and ABCG1 transporters, progressively increasing in size. In the blood, LCAT continues to esterify free cholesterol, and HDL3 is converted into the larger cholesterol-rich HDL2 particle. In this way, excess cholesterol from peripheral tissues is effectively loaded onto HDL. The cholesterol carried by HDL can return to the liver by two distinct pathways: direct and indirect reverse cholesterol transport. In the direct pathway, HDL delivers cholesterol esters directly to the liver into steroidogenic tissues. This process is mediated by the scavenger receptor class B type 1, or SRB1, which facilitates the selective uptake of cholesterol esters without complete internalization of the HDL particle. As cholesterol esters are removed, HDL2 becomes smaller and reverts to HDL3. These particles then recirculate to collect more cholesterol from peripheral tissues. Some HDL particles may also be taken up by the liver through less well-characterized HDL receptors. The cholesterol is ultimately excreted into bile, either after conversion to bile salts or directly as free cholesterol. In the indirect pathway, cholesterol ester transfer protein, or CETP, facilitates a bidirectional transfer of cholesterol esters from HDL to ApoB-containing lipoproteins, such as VLDL, IDL, LDL, and chylomicron remnants, in exchange for triglycerides. The net effect is a transfer of cholesterol from HDL to these lipoproteins. These ApoB-containing particles are eventually taken up by the liver, thereby returning the cholesterol indirectly. However, under conditions such as caloric excess, when LDL receptor expression on the cell surface is reduced, LDL particles may deposit cholesterol in peripheral tissues, particularly within macrophages. This makes the indirect pathway potentially atherogenic.